Okay, so let's try a Charles's Law problem where we solve for a temperature which is in the denominator. So we're going to work on number 5. Oxygen gas is at a temperature of 40 degrees C when it occupies, let's go ahead and circle our givens, when it occupies a volume of 2.3 liters. To what temperature in Celsius, so we're looking at T2, should it be raised to occupy a volume of 6.5 liters? Alright, so let's list our givens. We've got T1, V1, T2, V2. Our T1, this will be T1, is 40 degrees C, and remember you must immediately add 273 because your temperatures must be in Kelvin. Even though they want the answer in Celsius, you have to do the calculation in Kelvin. Alright, so we've got, oh well, it's 313, pretty sure. Yeah. Alright, V1, looks like V1 here, 2.3 liters. T2 is what we're looking for, and it's going to occupy V2 here, 6.5 liters when it's raised. Alright, so we've got our formula is V1 over T1 is equal to V2 over T2. It's Charles's law. And we want to solve for T2. T2 is in the denominator though. So the first move we have to make is to get T2 out of the denominator. So we're going to multiply both sides by T2 to get it out of the denominator. If you don't, then you're going to be solving for the reciprocal, which is not what you want. So we've got now to move V1 and T1 to the other side. So V1 is going to go down because we're dividing by V1, and T1 is going to go up because we're going to multiply both sides by T1. So we end up with our formula being T2 is equal to V2 times T1 over V1. Alright, so now we just need to plug in our numbers. We've got 6.5 liters for V2. T1 is 313 Kelvin. V2 is 2.3 liters. Liters cancels out. Kelvin are left. And we have 6.5 times 313 divided by 2.3. And we are limited to only 2 significant figures here, so we're going to need to put this in scientific notation, 10 to the second, to have the correct number of significant figures.